So I need to alert that actually. I need to update it.
Okay.
So it is what I learned is historically it supported Windows, only Windows, but now it's supporting Linux as well. But whereas coming to VMware, it doesn't care about what OS it is. It accepts the request.
Uh,
Okay, so I need to update it. And coming to VMware also, it supports like 2 TB of RAM and Hyper-V 4 TB of RAM.
mm-hmm.
The
Yeah,
server addresses, it can serve addresses up to
right.
4 TB of RAM.
Yeah, really,
And
I didn't mean to go into that depths of it. That's more into finding an opportunity in the virtualization space. I just wanted a comparison factor as to what it used to be earlier and where we are going today.
yeah, okay. I done couple of more points of it also. I think like what how many switches it can accommodate and so.
Uh-huh. That's good.
And it can yeah it supports 32 and 64 bits VMware, and whereas Hyper-V supports only it requires 64-bit host.
Mhm.
So that's the thing about differences. Whereas in hypervisors, I didn't find much. Like whatever you said, I found it on internet the same thing. Like it runs directly. Type 1 runs on the system's hardware, whereas Type 2 runs on an host operating system. And performance-wise, Type 1 is higher
Yes,
compared to Type 2. So that's what I made it. That's it.
that's good. That's good. So yeah, so Bandhavi, did you get an opportunity to install the VMware Workstation or Citrix or Oracle VirtualBox?
No, actually, I don't have my laptop right now with me
Okay.
because I had given it to repair and I'll get it by this weekend.
So are you using an iPad or something, a phone or something now?
iPhone.
Are you using a phone to connect now? Okay. Okay.
Yeah, I'm using my phone to connect now. Like from past 2 days, I'm doing that. So it's in Apple Store. So
Okay. That's a Mac, is it?
yeah,
Mm-hmm. All right. That's good. I really feel happy when you do a lot of your homework and come back questions. That's great. Keep up the great work. Um,
thank you.
let's go ahead and talk about these things, which are the operating system and how that works, etc. So I'm going to be using more of paint and pictures here. So although there has been a feedback as not to use paint and use Google Draw instead. So Google, yeah, Draw. So quick draw with Google, yeah. So people have asked me to use Google Draw so that I can share those pictures as well. But yeah, whatever is the comfort level. Hmm. Okay. So what's an operating system? What are the components of an operating system? Nothing specific with Windows, nothing specific with Linux or Unix or Solaris, but every operating system has a core and a shell, or called as a shell and a kernel. Um, there's a what's that? There's a not a fruit, but there's a fruit that's mostly found in the north. It's called the walnut, right? Walnut. Walnut. The outer part is called as a shell. The inner part is called as a kernel. We eat the kernel and throw off the shell, right? Similarly, in the operating systems, what you see inside the, or maybe just by looking at the operating system, what you see is the outer part. That's called as what? The shell, and the inner part is called as the kernel. So when there's a user, how do I make a user here? Let's say, yeah, that's it. When the user who seems to be happy user who is communicating with the operating system, he just looks at what's called as the shell. So what we see on top of it is a shell. The shell then communicates with the kernel to get and put information, right? So it's like you're launching an application to play music on your computer, and that application communicates with the hardware with the help of drivers. So drivers are sitting in the kernel, whereas the application is sitting in the shell. Most of the operating systems work this way, except that there are certain applications that just have what we call as a kernel. There's nothing else. So you will have just a medium to communicate with the shell, and you run commands, execute on top of it. The drivers, even these at times the operating system or a few components of the operating system will sit inside the shell. Okay. What are the different kinds of operating systems? Different kinds of operating systems. The client-based operating system. They're classified as client. Is there a text? Yeah. So they're classified as client-based OS and server-based OS. So they started with or the world of operating systems initially started with what we know as DOS today. DOS, right? So that was just a shell, nothing else. So on your computer, you will just install that command line thing. So even today we have this thing. So you open command prompt, that's called as a DOS. It's a DOS shell. Okay. Now inside this DOS shell, you can run various commands, but not everybody is happy to run commands. So what you will have on top of it is a shell that makes the life easy for the user, and hence you can easily navigate through the GUI. There are different kinds of operating systems. Client is started with Windows 3.5, then there is Windows NT 4, then came 4.5, the Windows 2000, and these have different flavors as well. Just like cars or phones have different models within that. If you want to buy a car, you will have LXI, VDI, a petrol version, a gas version, right? The different versions of that. So Windows 2000 also had different versions. Like there's professional, then there was data center, enterprise, right, and so on. Standard was also there. And then 2003 was released, and they had similar platforms. It was called as professional, data center. Well, 2003 did not have professional, it just had standard, and then data center, and then an enterprise edition. Then they released Windows 2003 R2 with all of those three flavors, S, D, and E, standard, data center, and enterprise. Then 2008 was released with standard, data center, and enterprise. Not just that, they released a core version which was totally command line. So in 2008 core, there is no GUI, or what American calls it as GUI. In UK they call it as GUI. So in 2008 core, there is no GUI. Then they released 2008 R2, which is release 2. So they had standard, data center, enterprise, and the core version. 2012 they had SDEC, and 2012 SDEC, and this one was R2. What I have listed is the server-based operating systems. All of these were server-based operating systems. So they were at the server end. Right? And then there's client-based OS. What are they? I'm just listing out the Windows, not the Linux ones. Okay? The client-based OS, like what? It started with Windows 95, 98, and then 2000. 2000 Professional was a client-based operating system. And then Windows Millennium, heard of Millennium? Whatever the spelling is.
No.
Windows Millennium, also called as Windows ME. Windows ME. It was there. There was a flop edition. And then came Windows XP that lived for a very long time. Then Windows Vista, that was not that appreciated. Windows 7 stayed for a very long time, and you still see I'm using Windows 7. Then Windows 8, and you know the life after that, Windows 10. Keep in mind that each of these operating systems also have flavors. There's Windows 2000 Professional, the Windows XP Home, Windows XP uh, Professional, Home Edition, Media Center Edition. There's there. So difference is that when you're using Windows XP Home, that laptop cannot be used in corporate environments. Okay? It's just that the ones which have professional can be used in corporate environments. Make sense?
Yeah.
There's a bunch of operating. Now I'm just talking about the Windows side. On the Linux front, there are various operating systems again. So Linux is open source, as you know. There's Red Hat, Ubuntu, Fedora, what's that? SUSE, Kali, Backtrack. The last two ones are used for ethical hacking purposes, because these two operating systems will have lots of tools to hack into somebody's environment. CentOS, so the hackers are using those two, Kali, Backtrack, and some people customize their own tools as well. Red Hat is the most famous one because that's commercial commercial Linux operating system. Is Ubuntu, Fedora, SUSE. SUSE is also used at the enterprise level, Ubuntu at the desktop level, CentOS at the desktop level, right? Have you heard of SAP? SAP?
SAP.
Yeah, SAP.
I know that it was not supposed to be called as SAP, but instead it should be called as SAP.
Yeah,
Um,
so there's
it's an ERP. Yeah.
there's a module in SAP which is called as SAP HANA. That sits on
HANA. Yeah.
that sits on SUSE platform, because SUSE is the most
Okay.
robust of those. All of those SUSE and Red Hat are the most robust operating systems in the Linux area. They can be used for both desktop as well as on the server end. Okay, so that was about the operating systems. So lots of commands within these operating systems that you can run here. Make yourself comfortable with, making directories like cd slash, then mkdir, alpha. That will create a folder. Mkdir stands for make directory. Alpha is the name of a folder. So um, if I see the dir here now, dir, I will see a new folder called alpha. I just created a folder called alpha. You can create another folder mkdir beta, so that will create a folder called beta somewhere here, right? So CLS will just clear the screen, right? ipconfig will show me the IP address that's on the machine. CLS clears up all the screen. So go ahead and look for what? DOS commands, right? DOS commands used in Windows. We can practice that, right? DOS commands used in Windows. Are we comfortable so far?
Yes.
Okay. Put all of this.
Yeah.
Okay. Let's talk about networking. You've been from the Windows world, you will very well know what is LAN, WAN, and WAN, right? You've been from the IT computing world, so you know what is LAN, WAN, and WAN, isn't it?
Yeah.
Right? How do we know what is a LAN, WAN, and WAN? I'm gonna mute you because it's in background. Nice. The music is really nice, but I'm gonna mute it for now. All right, thank you. So Bandhavi, you know what is LAN, which is local area network, WAN and MAN. LAN stands for local area network, WAN stands for wide area network, and then MAN stands for metropolitan area network, right? So when you are talking within the same building or the premise, that's called as LAN, local area network. So you got, okay, I didn't see the chat. I just saw it now, Bandhavi. Thank you for your response. So when there are multiple computers which are talking within the same premise or within the same building, like you got a couple of laptops within the same house or same home, they will be talking within each other. They're not talking to the computers outside or at your neighbor's house, right? So that's a LAN within your local area. Wide area network is when two buildings are connected and they are talking within each other, and it could be between two geographies as well. So one building is in Kenya, another building is in South Africa, but then both of them are connected with the help of ISP. That's wide area network. Metropolitan area network is within the city, so where where the connectivity is there between the cities itself. Yeah. So there are different network topologies as well. There's hub and spoke, and there is bus topology, hub and spoke, bus topology, ring topology, and there's mesh topology. So it's all about the way you are setting up the network, correct? So let's say you've got you're setting up a network and the computers are connected end to end. That means that you got one computer like this, you're setting up one, and then you're setting up another one, and they are like connected end to end like this. Then the connectivity between them is direct like this. So this is kind of hub topology. Sorry, this is a bus topology where machine A is connected to machine B is connected to machine C, and machine C is connected to machine D. Or machine D is not connected to machine A. This is bus topology, right? A mesh topology.
Yes.
Yeah. So a mesh topology is where every computer in the network is connected with every other computer. So I will be drawing lines left and right. So that's going to be that. So I'm saying that every computer is connected to every other computer. So I'm going to draw as many permutation combinations as possible. So that's going to be my mesh environment, isn't it? So every computer, so this talks to that talks to this. That really creates a whole lot of traffic in the environment, and also waste of resources as well, right? This is a mesh topology. Another topology which is called as a ring topology, where you will have center, in the center you will have one machine, but then there will be other machines which are connected around it like this. That's kind of what? Star topology, right? That's a star. So you will have connectivity like this. That's a star topology. We spoke about bus, ring. Oh, we did not speak about ring. Ring, as the name says, it's going to be circular in fashion. So you got one computer here, another computer next to it, another computer next to it, another computer like that, and that's how it is, right? And then if I have to connect them, they'll be connected like this. So there's always going to be a problem if machine A, which is on the top left hand side, let's say that is machine A, and machine A wants to talk with this guy, it has to go via B and C. This is A, B, C, and D. Machine A wants to talk with D, there's going to be a delay, there's going to be late. The machine A sends to B, B processes it, B sends it to D, D processes it, sorry, C, and then it's finally sent to C. So there's no best thumb rule as to we say that okay, this is the best particular topology. We use it depending on the kind of network we want to set up, right? So let's say this is a site. This is a site which is located in Middle East. This is a site which is located in UK. This is a site located in Germany, and this is a site located in Japan, and this is somewhere down southeast. So when such a scenario arises, when you got offices like that, you will go for star topology like this, right? You cannot go for a mesh topology. It's going to be expensive. Okay.
Yes.
Talk about IPv4 addresses. IPv4. What's an IPv4? How does an IPv4 address look like? Can you tell me one of the IP addresses? How does it look like?
192.168 dot like 100 dot
100 dot.
101.
Okay. So that's going for machine A, right? So let's say that's the IP address for machine A. And I'm going to give another machine as well. I'm going to make up another machine called as machine B, right? And give it an IP which is 192.168.100.102. There are two machines, right?
Yeah.
And if you do IP config on that machine, you will see that it also has something called as subnet mask, which is right here, right? Right?
Yeah.
Okay. Subnet mask.
Physical. Yeah.
Subnet mask is 255.255.255.0. And where are we going right now? I'm going to tell you about why and how two machines talk to each other. That's what I'm talking about. And how two machines identify whether they are in same network or different networks. So you got machine A with that IP, machine B with another IP. There's subnet mask, and both of them are in the same network, and that's why they have the same subnet mask. Let's say you got two laptops, or maybe your laptop and your friend's laptop, which will have the IP of 101 and you will have an IP of 102. The subnet masks will be the same because it's the same router that is giving out the IP addresses to you. Okay? Okay. Computers do not understand these numbers. We as human beings can remember these numbers, but we do not remember these numbers. So what we got to do is convert these decimal numbers to binary, right? So what is 192? Remember the school maths? What is 192? 192, I'm going to pick up and open up the calculator because I don't want to put my brains there. So I'll say view and say programmer and say 192 is 1 1 and all zeros. So it's going to be an octet. An IP address has 4 octets. This is an octet, that's an octet, that's an octet, that's an octet. Why? Because it has 8 digits. Okay? Alright. Let's go ahead and do the decimal for 168 binary. That's the number. Okay? Dot. And you said 100, right? 100 will be called as 4. Uh-oh. Yeah, it's 4. Yeah. So I got 100. 100 is what? 100 is that. You put here. And then you said 101, isn't it? 101 is a decimal. Are you following me, guys?
Yeah.
I don't want to be rushing around.
No.
Good, okay. Let's do the same thing for machine B. And we have noticed that at this point, the numbers are same. So you're going to just copy that.
Yeah.
Copy that. Paste it. And all we got to do is now convert 102 into binary. Like that. Okay. That was fun to play with. Good. Now we're coming back to subnet mask section. I want to tell you that 255, the numbers 255 is all ones. Right? That's easy to remember. 255 is all ones, so that's all ones dot all ones dot all ones dot all zeros.
Zero.
Right?
Yeah.
Then It's gonna be same thing here. It's 255, so 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8. Okay, that was a good exercise. Now I want to where can I draw a table? Alright, that's good. You can draw a table. But what I want is 3 by 2 table. Yeah, that's what I want. And you from the computer's background, you know what an AND operation is, right? AND operation. AND operation.
Yes.
So it's an A, and it's a B, and that's C. Okay, oh, or maybe say O, which stands for output, right? If the value of A is 1 and the value of B is 1, then the output is 1. If the value of A is 0 and the value of B is 0, the output is 0. If the value of A is 1 and the value of B is 0, then the value is 0. If the value of A is 0 and B, if the value of A is 0 and B is also 0, then output is also 0, right? Now what we got to do is do an AND operation between whom and whom? Machine A's IP address and subnet mask and machine B's subnet mask.
And we.
Yeah. So what we have to do is write the output, right? The output of machine A is 1 and 1 is 1. Then again 1 and 1 is 1. And because it's all zeros here, right? And then it's all ones. So what's the output here? 1, 2, 3, 4, 5, 6. Yeah? Does that make sense? Why did I put that there?
Yes.
By the way, does that make sense for you as well?
Yes.
Okay. Now let's do the AND operation. Let's do the AND operation of this and this. That will be 1, 0, 1, 0, 1, 0, 0, 0. Isn't it? 1 and 1 is 1. 0 and 1 is 0. 1 and 1 is 1 again. So that's how I got that. Okay?
Okay.
Then I'll do the AND operation of this part and this part, which will be 1, 1, 0, 0, 1, 0, 0, 0. There's 1 0 missing out here actually. Maybe a 0 out there. Similarly here, a 0 is missing. Anyways, and the output will be 0, 1, 0, 1, 1, 0, 0, 1, 0, 1. And I'll do the same for machine B. So I'll get the same output. Put that here, 1, 1, and then I'll have 6 zeros, dot, 1, 0, 1, dot, 0, 1, 1, 0, 0, 1, 0, 0, and 0, 1, 1, 0, 0, 1, 0, 1. Did you understand the output? How did I get the output so far? Vivek and Bandhavi, you understood how?
Yes. Yes.
Yeah, Vivek, you also got that? Yeah?
Yes, I did.
Okay. So now, if you look at this and this, the outputs are same. So that means, what does that mean? Two machines in the same network will have same output. And that is how two machines will recognize if they are in same network or not. If the output is different, they are in different networks. If the output is same, they are in the same network. Okay? Right.
Okay, I got it.
Okay.
Okay.
Yep.
Now, I want to tell about ports and protocols now. Ports and protocols. Well, there is nothing much we can do about it apart from memorizing them. Right? So when there is a communication happening between one point to another point, you will need some medium. medium which is physical. It could be wireless or wired. Not only that, you will also need ports and protocols. So for machine A to communicate with machine B and get a website information, you will need HTTP traffic, and that needs port number 80. Similarly, HTTPS has port number 443, right? Then there is FTP, which is using 22. SSH is using port number 22. Then there is RDP, which is remote desktop protocol, using port number 3389. LDAP is using what? 389. And this Kerberos, which is mostly used for authentication purposes, is using port number 88. Then there is global catalog, which is using 3268. I can just keep on going. I can actually share a list of it's right here. Let me share you a picture actually, which has a well-known ports that you may have to remember. That's it. That's what you gotta remember. All of those ports. FTP using port number 20, SSH 22, Telnet 23, TechAX 49, DNS 53, Kerberos 88, SNMP 161, LDAP 389, HTTPS 443. So you gotta remember all of those. Okay?
Yeah.
You might have heard about all of these things in your masters as well, right?
Yeah, like port numbers and all, yeah, we came across.
Right. Okay. Now, I'll go back to a picture here. Well, I'll just get rid of this garbage and okay. Question for you, okay? An exercise. You have a server here, right? You have a server here, which is in your home, right? Which is at your home. This server is connected to your Wi-Fi or the router. That's the router. Now, you also have your laptop which is connected over Wi-Fi. This is a web server and this is your laptop. This guy is your laptop. You are trying to access the web server by typing in http:// the web server name, right? Now the question is, on this firewall or on this router, what port should be open? This is your laptop, this is your laptop, and that's your web server, that's your router. From here you're trying to access, on the laptop you're trying to access the web server name. The question is, which port is open from the laptop to the web server, and what port have you opened on the router?
Probably HTTP 80.
Perfect, yeah.
80,
Yeah, that was a
80,
very
yeah.
simple. Yes. Right. Now we will construct more and more scenarios around it. Now, how do you write a rule? You have to write a rule on the router, right? And the rule constitutes of the following. Rule says you gotta put up source. You also need to have destination, right? And the protocol, right? The port number and the status, where you will write the source is the IP of laptop. The destination is IP of the web server, the protocol is TCP, the port number is 80, and status is allowed. Okay, this is the kind of rule that you write on the firewalls. That's how you write it. Now what I'm gonna do is, you're writing this rule because there is a firewall in the middle, and I'm gonna put a corporate firewall right here which looks something like this. That's a corporate firewall, and you have to open the ports from this network, which is network A. This one is network A, and then you open from network A to network B. That's network B. But let's say you got lots of machines on this network like this, and here also you got lots of machines like that, bunch of machines. All right, there's just too many machines out there. One of them is, same example, one of them is a web server. Oops, sorry. One of them is a web server, and you want all of these machines, to talk to this web server. I want you to write a rule now. Which one will be the source? What will be the destination? Ports and protocols, and what's the status? For one-on-one mapping, you are able to write it. Now you have to do multiple to one mapping on the router. Food for thought.
Using the instead of particular IP one-on-one, we can use the subnet IP address of that particular network.
You are going the right way. Absolutely the right way. So let's say you got this entire range machine. There are 15 machines, right? There are 15 machines here, maybe 20 machines. So what you do is 192.168.30.5 is the IP of machine A, and then like that you will have 192.168.30.25. There's 30.5, 30.6, 30.7, 30.8 till 30.25. But all of them, since they're in the same network, they will have the same subnet mask, isn't it? So what you now have to define, is a CIDR, or what Bandavi was saying as network ID. Here, let's say the subnet mask is 255.255.255.0. Then the CIDR, or the network ID, will be 192.168.30.0 slash, now 30 is a network ID. I'm just stopping here, and the rest part, which is dynamic in nature, dynamic means it is constantly changing from host machine to host machine. I will just leave it to 0 and mark it as 24. I'm saying 24 because there are 24 ones. This has got 8 ones, this has got 8 ones, and this has got 8 ones. So it will be 192.168.30.0 is a network ID for all of these machines. How many hosts can I have when I have /24? When I have /24, wait a minute. When I have /24, I can mathematically have 255 machines /hosts, but no machine will get this IP. Okay, because this is used for broadcasting in the network. So essentially you will get 254 IPs. Amazon doesn't even give 254, it gives 251, and it reserves the 3 IPs, or whatever the balance 3 IPs it has. Okay, so when this network, you will be able to get 251 IPs. This is the CIDR, also called as variable length subnet masking, called as VLSM. So in this you will have 255 machines. This is the network part. That means every machine will have this same number, but then this part will constantly change. Okay, any questions?
No.
No. No.
Okay.
Can you, one quick question, like
Sure.
you got 192.168 30.0/24. So you said that it's four ones. Like, can you say that again? That concept. Like, why did you write 0/24?
Yeah, how did I write 0/24? Now this part is the IP address part which I'm writing, and this represents my
Okay.
subnet mask because it has 24 ones. 255 has 8 ones. This 255 is another 8. This 255 is another 8. So 8 plus 8 16, 16 plus 8 24.
Okay, so we previously we thought that we have only around 20 computers, like 20 laptops here, which connected to this web server. So when we can allocate the remaining laptop, you mean, like how is it?
Yeah. So if you put this in the source, you are actually allowing all the 255 machines to communicate with the web server.
Okay,
So here the source will be 192.168.30.0/24 to the IP address of the web server, TCP port number 80 allowed. Okay, good so far?
Yeah.
Vivek?
yes.
Okay, great. Now what if you want, I'm gonna should I delete this or yeah, okay,
Now we need it.
you need it.
I want it to save. Yeah.
You want me to save all of these pictures?
Yes.
Okay, where is that save? Where is save? Download as picture. Okay, download as PDF. Okay, all right, that's downloaded. You want me to save this as well? It's all here actually. It's all here. Okay, so I'm gonna get rid of couple of items for another scenario. Okay, quickly. I'm just getting rid of all of that. Okay, let's consider that this is your internal LAN. This is your local area network where you're hosting a very important web server. Okay, I should not have moved that. It's a very important web server. And now the customers who are outside your network, couple of customers who are outside your network needs to access it. Is there an icon which looks like a cloud? Oh yeah, there it is. Customers from your external environment needs to access. What do? You got to write a rule on the firewall now. How will you let your external customers access your web server?
Maybe by giving the permissions.
Rules, right? No, it's not permission.
Yeah.
They call it as
Okay.
ACLs.
No,
Yeah, they call it
login details.
ACLs.
Ac-
It's not permissions. We call it as ACLs, which are called as access control lists. So that should be written. So instead of a particular range here, you know what you will write? You will write, I'm not able to modify this. How do I modify this? Okay, got it. Crazy. Okay. Instead of this, you will say 0.0.0.0/0, which is the internet. 0.0.0.0/0 means from everywhere. Okay?
Mhm.
Or you can give the public IP of the customer, whatever is a public IP. Okay?
Okay.
All right, that's good. So we understood IPv4. We also understood I can email these things to you. You can put your email addresses privately in the chat. So I'll email these pictures to you if you want them. Okay, also download this one file. Download as the PDF. Okay, that's good. All right. And any questions, guys? While I look at the training agenda. Okay. Do you know what DMZ is? Demilitarized zone.
No.
No.
Okay, I'm gonna draw a picture again and now explain you about what a DMZ is. All of these things you may be thinking are not related to the cloud computing, but I'm just trying to make sure that your foundations are strong rather than just jumping into cloud. I mean, it will really make my job a lot easier, but then I don't want to get into any easy job. So I want you to understand how the technology worked earlier, so that way you will have a comparison factor. Yeah. Now we're talking about DMZ, which are called as demilitarized zones. Let's say you got your customer somewhere. Yeah, customer is right here, and you have your environment. You have your environment behind a firewall, and that's good. So you will have a couple of servers here. That's a 1, 2, 3, 4, 5, 5. All of these are servers. Or one of them is a web server, which is meant only for the customer. So, and you've written rules as well. You've written rules and policies on the firewall. So now the customer is able to get in, get his request processed through the firewall. And once that is done, customer can access the web. But there is always a chance that customer can linger around the web server, and from here he can get in to your corporate network. Right? So he can get into your corporate network somehow. Is that an arrow? Right. So there are chances that customer can get in there. So what you do is keep all of your infrastructure safely somewhere apart from the DMZ, apart from this environment. And what you do is create another firewall. You will create another firewall right there. And you will not open any ports here except that these guys should be able to access the web server, but from here there should not be any communication to the internal environment. Right? This part is called as the DMZ. So the area between the firewalls is called as a DMZ. You can just Google around pictures and type demilitarized zone and just look at images. You will get similar images there. Let's pick up, oh, this is you got network security right here. Okay, so that area between these two firewalls is called as a DMZ. You got all of these pictures with different infrastructure diagrams, right? That is a DMZ network. All right.
Okay.
Okay. What's the load? Thinking about it, what's a load balancer? Load balancer is something that balances
So,
load. Load balancer is something that balances the load between, just a moment. Okay. So load balancer is something that balances the load between the servers. So that's again your internet and from there there's going to be a bunch of traffic that's going to hit your internal environments. So first what it needs to do is hit a load balancer. So let's create a load balancer first, and let's say that's your load balancer, and behind the load balancers will be several web servers. So that's web server 1, and that's web server 2, and that's web server 3. So there's a user out there who's now trying to access information. Is that a user? Yeah, that's a user. So the user who's trying to access an e-commerce website through the load balancer. So the traffic number 1 goes to web server 1, traffic 2 goes to web server 2, traffic 3 goes to web server 3, traffic 4 goes to 1, traffic 5 goes to 2, traffic like that. The traffic will be distributed in a round robin fashion, so that the load is not there on one particular server. It has to be distributed between servers. So that is the job of a load balancer. Okay?
Yes.
Okay.
Okay, so you know about all of this. Right. Do you have an AWS account already?
Yeah, I do have.
Okay.
Yes, I do.
Okay. Great. Great.
I can log in.
Have you created machines there, virtual machine or something in the cloud sometime?
No.
Okay. Bandhavi, have you created a machine there sometime?
No.
Okay. Hopefully you're gonna get your laptop pretty soon, so we can do some labs out there. I think we did a Gartner comparison as well. So it's time we start, jumping into cloud and slowly um, get you habituated to the cloud jargons as well, like EC2 and things like that. And then as and when required, we'll move off topic and start introducing the way it worked in traditional world as well. So that ways you will have some hands-on, some theory, some hands-on, some theory. We're gonna keep a mix and match of it. That ways it will be interesting as well. Yeah. So okay. I'm done for the agenda for today. I'm gonna email these things for you if you need it. You can put your email address in the chat, and then I can take it off from there. For now, I would like you to read
Sure.
I would like you to go ahead and read how DNS works, right? What is a forward lookup? What is a reverse lookup? I would also like you to read different types of records in DNS and their purpose. I would also like you to understand how DHCP works and what is DORA process, which is discover, offer, request, and acknowledge. If you know differences between private IP and public IP, that's good. If not, take a look at that. Also, classes of IP addresses, which are class A, B, C, whatever till E. So you can take a look at that. I'm sure you will know most of these. You might have heard of all these things in your graduation. It may just be brushing up your skills or something. Yeah, it will be great if you can brush up those things that you have already learned in the past. So that ways you'll be really fresh when I'm talking.
Okay.
Okay, great. And that's your homework in the chat. Okay. Guys, any questions for me?
No.
Okay, great. Thank you so much for your time. I would really appreciate if you can give me feedback time to time, so that ways I will know my areas of improvement and we can make the training better, right? It's not a one-way interaction. I would like a duplex interaction than just me talking. If you can talk and let me know, hey Anand, that's not going right. Let's fix it. Let's do that. I'll be more than happy to introduce your way of learning. So Anyways, yeah, with that note, we end the class for today and see you guys tomorrow with good health and spirit.
Thank you.
Thank you. Bye bye. Madhvi, bye.
Bye.
Good night, Vivek. Bye.
Bye bye.
Well, it's
Bye.
good night.
Right. Bye-bye.
Good night here. So saying good night to you as you have a good day. Bye bye.
Thank you. Bye-bye.